Of course, that's always equal to 1 if the radial vector and the momentum vector are always perpendicular. So that's why you don't see it in the circle equation. But when that's not true, when we're dealing with an ellipse, it's true at these 4 points specifically. But if you take this point, for example, the momentum vector is definitely not perpendicular to the radial vector. So when you change the orbit shape up, sine theta now actually becomes something that can be factored in. But here's the real kicker. This only, let's not pull it up that way. The real kicker is what happens when you try to turn things from 2D to 3D. Let's take, for example, the spherical pendulum, which is just an object in 3-dimensional space that is given some initial position and velocity, and that is free to move around the 3D sphere, with its only limitation being gravity, and of course the length of the string, not allowing it to go closer or farther from the center. So, in this case, as you can see, its plane of rotation is constantly changing, which means that at 2 completely different points in the object's trajectory, everything about it, from the angular velocity to the angular acceleration to the angular momentum, could be the same, and yet the situation of these two is totally different because of the way gravity acts on them. So that means that we have to figure out some way to express the plane of rotation for these guys too. And the easiest way to do that is just to, well, how do we ever associate a plane with a vector? Well, we can just pick its perpendicular. It's not worth it to try and look for the vector that's encompassed by the plane, because the vector encompasses 2 vectors as well as the span of the 2 vectors that generate it. So it's pointless trying to look for the singular vector that encompasses the entire plane, but there is one singular vector, and of course all of its scalar multiples, but there's one singular direction that is exactly perpendicular to this plane. And let's set that to be the direction of omega, alpha, L, all the funky angular quantities.